What's up, math scholars? Christy Harp here. I'm going to try my best to record this video on my laptop because my microphone won't connect to my smartboard anymore. For number 1, we're taking nth root of a, so that's the cube root of -8. There is a button on your calculator. If you go in the math menu, it's math 4. That's going to be -2. For number 2, we're going to be doing the 4th root of 256. If you type that in your calculator, it's only going to tell you 4. So you have to be smart enough to realize a 4th root gives 2 answers, plus or minus 4. Evaluate without using a calculator. That means we're going to put it into radical form. The denominator becomes the index of the radical. So we're going to be cube rooting -27 and then taking that answer to the 4th power. So it'd be -3 to the 4th power. That's going to be 81. Finally, we get to use our calculator, so you just use that math 4 button and then round to 2 decimal places, so -13.31. All right, heading down to number 5. Bigger minus smaller, put your answer where the bigger lives, so we're going to have to do the 2/3. Oh, nope, sorry, I said that wrong. I would actually flip and make it positive first, my bad. So we're going to flip and make the exponent a positive, and then they're actually going to just be adding the exponents. 2/3 plus 1/3 is 3/3, and 3/3 is just a 1. So my final answer is 3 for number 5. Number 6, we're going to have to get these to be like terms. They're not like terms right now. I'd factor the 8 down into radical 4 times radical 2. I'd factor the 18 down into radical 9 times radical 2. The square root of 4 equals 2, and then when this 2 joins the 8, they will multiply to become 16. The square root of 9 is 3, and when 3 joins that -4, they'll multiply and become -12. And then they're like terms. If you have 16 radical 2's and you subtract off 12 radical 2's, it's 4 radical 2's. Number 7 is pretty easy. You just need to add your exponents. So we need to take the 2 and add it to the 3/4. To do adding, though, you need common denominators. To turn 2 into a common denominator, I can multiply the bottom by 4. The bottom right now is a 1. So I multiply the top by 4 as well. So 8/4 is equivalent to 2. When I add those up, I add my numerators and get 11, but keep my denominator of 4. So y to the 11/4. Finally, number 8 is so easy. I'm not even sure why it's on here. You just add your exponents. I think any 8th grader could do that problem. Number 9, we're going to simplify the radical, but you need your list of perfect 4th roots. I can see my list from here if I look real hard. 1, 16, 81, 256. So 256 is obviously too big. It's 81 that we want. So it's going to be the 4th root of 81 times the 4th root of 2. The 4th root of 81 is 3. I'll put that out front. The 2 can stay in the radical. And we're going to use long division to deal with our exponents. 14 divided by 4 is 3 with a remainder of 2. Now the remainder tells us how many stay in jail. So it's 2 stay in, 3 get out. And then I'll do my y's. So 8 divided by 4 is 2, remainder 0. So no y's stay in the jail, but 2 get out of the jail. Number 10, we need to get everybody in the same radical together to be able to do this problem. So we're going to cube root 25 times 10 gives us 250. X to the 4th with x squared gives x to the 6th. I'm going to break down the 250 so one of the numbers can be a perfect cube root this time. I can refer to my cube root list on the board. 125 is the one catching my eye. So the cube root of 125 is 5. It can come out front. The 2 can stay in the jail. And then I can just do this 6 divided by 3 and get 2 remainder 0. So that's my answer. Looks like Christmas right there. All right, we have a lot going on this slide. We have to do g of -2. So we're going to start with g of -2. I'll put a -2 right here. Please make sure you're using parentheses. That should have been a squared, sorry. 3 times negative 2 squared would be 3 times 4, so that's 12. So my intermediate answer is 12. But now I still need to do another g of 12. So I'll be putting a 12 in for x. That's 3 times 144, which is 432. This next one's actually going to require a little foiling. I basically have to take my inside function, my f of x, and put it in function g. Put it in there. That means stick it in for x. So you'll have 3 with the parentheses 4x plus 2 that you are squaring. That means I'm going to be foiling 4x plus 2 with 4x plus 2. Actually, I'm not going to foil those two. I'm going to take my 3 into my first group, make it a 12x plus 6. Then I'll foil it with my 4x plus 2. So first, outside, inside, last. 48x squared, 24x, 24x, and 12. Your final answer is 48x squared plus 48x plus 12. And finally, part C. Not much space left. Let me scroll a little bit. F plus G, you're just going to add the two up. So F is 4x plus 2. G is 3x squared, and I'll put it into standard form. That's your answer for 11C. Let's see how far we get. This is going to be a 2-part video series. I'm going to be running out of time to do it all in one part. 12, are they inverse functions? So this is almost like a proof. You're going to do f of g of x first. So we'll circle g of x and plop it right in there with our parentheses. And we're going to see what happens when this occurs. When I distribute my 2, I'll get 1x. When I distribute my 2, I'll get negative 2. Then I'll have a plus 2. Notice these go away, and I'm left with an x. So that's good. The first direction works. Now we have to go the opposite direction. G of f of x. So I should probably erase my marks up here. So I can show you how we're going to go the other direction. To go the other direction, we circle f, we put it into g. So it looks a little different, similar but different. It'll be 1/2 first, then our parentheses, 2x plus 2 minus 1. When I distribute, I get a 1x, then I get a positive 1, then I have a negative 1. These two cancel, leaving you with x. So both directions work, so I would say yes, it's an inverse. It's like a math proof, so you have to go both directions. 13 is my favorite. I have a song for inverses. Switch the x and y, then resolve it. Now they do have a restriction on the domain. They're saying that so it remains a function. If x's were negative, it wouldn't be a function. The f of x basically acts as our y. I'll just do my work for 13 up here. To switch, it'd be x equals 1/16 y to the 4th. And the steps we can use to solve are multiply by 16 first, and then take the 4th root on both sides. So you can either leave it 4th root of 16x, and I'm going to call it f inverse of x instead of calling it y, or you could probably 4th root the 16. They do say we want x's to be positives only. So I'll just say plus or minus 2 4th roots of x. So the 4th root of 16 is plus or minus 2. So either this answer here or this answer here would probably be fine. Number 14, I'll do it down here. We have some space. Switch the x and y. Oh no, must have bumped something. Switch the x and y. So this is now an x because that was our y, and this is now a y. The steps to solve will be multiply both sides by 3, then subtract your 5 to the other side, then divide by 2. So it's 3x minus 5 over 2. And again, I'm going to call it f inverse of x instead of calling it y, because the original function had an f of x in it. The negative one means inverse. 15. Looks like we're subtracting the two functions. This one's a little difficult, I'll be honest. We're subtracting the 16x to the 3 halves. What makes this difficult is this 3 halves has to go the 16 and the x. If you're going to do 16 to the 3 halves, you can either type it in or do it by hand. It's the square root of 16 cubed. So that ends up being 4 cubed, which is 64. So 64x to the 3 halves and 4x to the 3 halves. We lucked out, they're like terms, so we can combine them. If you have 4 apples and you subtract off 64 apples, you have negative 60 apples. So negative 60 x to the 3 halves. We're doing good. We're getting pretty far on this first video. 16, we just did this in section 3-6, which was today for me. We're cubing both sides. 4 cubed is 64. And then we'll add the 8 to the other side, which is 72. And then we'll divide by 2, and that's 36. That answer would definitely work if you checked it, because you can cube root anything, positives or negatives. Now this next one's for sure a challenge. You're going to start by subtracting your 2 to the other side, and that gives you 4. And then it's going to get weird. We have to use, oops, should have been a 2. We have to use a reciprocal power. So I'm going to take both sides to the 3 halves power. Now, we did a problem like this in the 3-6 lesson, or the 3-6 Polaris assignment. If you're square rooting 4, and then you're cubing it, it's technically plus or minus 2 cubed, so it's plus or minus 8. But here's the trouble with that. If you have x squared minus 1 equaling plus or minus 8, when you move the 1 to the other side, positive 8 plus 1 is 9, but negative 8 plus 1, negative 8 plus 1 is negative 7. I can't square root a negative without imaginaries, so we're just going to stick with our real solutions to this problem. It's plus or minus 3. And I checked both of those, and they did both work, so we were a little lucky. This is our FOIL problem. When you have to square both sides, you actually need to FOIL x plus 2. So you write it twice, and you FOIL it. The result of my FOIL was x squared plus 4x plus 4. My strategy here will be get everything onto the left-hand side. So I'll add my x over. Did I mess something up? I'll add my x over. I messed something up on my answer key. I'm going to fix my answer key. I'll subtract my 24 over, and I'll finish with factoring. So to factor would be a positive 8, and I believe a negative 3. So that makes my answer 3 and negative 8. The negative answer is normally extraneous on these. If you would check it, you would end up having a square root equaling a negative 6, which is not possible. So it's actually x equals 3. Fixing my answer key real quick. X equals 3. All right, I think 19 will be my last problem on this video, and I'll finish the rest on a separate video. Squaring both sides, this problem's so easy, the square roots go away. If I subtract my 3x to the right, I have 1x. If I add my 2 to the left, I have a 7. So 1x equals 7. Thanks for joining me for the first portion of the video. We'll be able to finish the next video rather quickly. It's just a few graph problems. Bye.